This week we will be discussing soil pH. The main things that I want you to get out of this lecture is to understand the importance of pH, what is soil pH, and explain how soil pH affects plant growth. pH is the measure of how acid or how basic the soil is. And this could be measured through the concentration of hydrogen ions in the soil. So, soils with an abundance of hydrogen ions is going to be more acidic with a lower soil pH. Soils with a lower amount of hydrogen ions is going to be a more basic soil pH with a higher soil pH. Soil pH ranges between 0 to 14. So 7 is in that middle range, and that's neutral. So anything lower than 7 is considered acidic with a higher amount of hydrogen ions within the soil. Anything above 7 is considered basic, and it has very little hydrogen ions within the soil. The ideal soil pH for most plants are between 6 to 7.0. And usually the limits for soil pH on plants are between 3.5 and 10.5. The soil pH scale is a logarithm. Each number on the pH scale represents a jump of 10 times the number of free hydrogen ions within the soil. So, how do soils get their pH? They may get this from their parent material. Their parent material determines the pH of young soils. So, basic soils, and those are soils with a pH above 7.0. And these basic soils are in the purple area. So, this is the area of the Midwest region. This area, limestone, is the most prominent. So, we're going to have soils with a higher pH. Now, acidic soils are most common on the East Coast, where granite and sandstone and shale are the most prominent parent material. And these are going to have a pH below 7.0. The weather may also affect soil pH. Basic soils are found more where precipitation is less than evaporation. So these are places with very little rainfall. Compared to acidic soils where precipitation is greater than evaporation. Other causes of acidic pH soils may include acid rain. And acid rain occurs when chemicals enter the atmosphere and dissolve into cloud water. These form new acids. Then the acids fall to earth as acid rain. Plant growth can also promote acidic pH development. And this is due to respiration from roots and soil animals as they put CO2 into the soil where it can react with soil water. The plant growth and decay of organic matter acidifies the soil. So, how does pH affect plants? pH affects plants in three ways: the nutrient availability, 2, a buildup of toxic chemicals, and 3, an effect on soil microbes. The nutrient availability is very dependent on the pH of soil. The ideal range is from 6.0 to 7.0. The nutrients may become bound up or unavailable at certain pH levels. So as you can see here on this photo, where it's very thin, it's deficient. And it's when it's very wide and thick, there might be an overabundance of nutrients, so it may be toxic. Okay, so when it's very thin, it's deficient, and when it's very wide, it could be toxic. But if you can see from 6.0 to 7.0, it's in a very good range for all of the nutrients, right? All of them. And that's what we want. We want the availability of all of these nutrients together, not just one or the other, but all of them. The absolute perfect range is a pH of 6.5. This is where the majority of all of the nutrients are at an available range with no toxicities or deficiencies. Now, at certain levels of soil pHs, some elements may become too available, and this is when they become toxic. We have issues within clay of aluminum, manganese, and iron. And these levels become so overabundant that they are toxic. So it is true that too much of a good thing may become toxic. So in this case, we have an abundance of aluminum, manganese, and iron, and this results in a toxicity in the soil, making the nutrients unavailable to the plant because there's an overabundance within the soil. Now, soil organisms with the micro and macrofauna prefer soil pH to be about 6.5 to 7.3 to perform optimally. Now, each plant has a preference and a tolerance to soil pH. And the soil pH is pretty difficult to change, especially if you have a high soil pH and you want to bring it lower. So instead of trying to change your soil pH, instead you should select a plant that does well in that specific pH for your site. Hence planting the right tree for the right place. So if you did want to change your pH, you can apply different amendments. So here with acidic soils, and that you need to raise the pH, applying lime is going to be your best option. The following are different materials that you can neutralize pH and reduce the acid in your soil. But just note that you have to reapply these materials to maintain the pH, and this is not a one-time fix. So we have calcium carbonate, calcium oxide, calcium hydrate, magnesium carbonate, magnesium oxide, and magnesium hydrate. So you may be asking yourself, why lime? Why lime exactly? Lime improves the nutrient uptake in acidified soils, especially phosphorus that's needed. This also reduces those different toxicities that we talked about, mostly the aluminum aspect. It reduces that toxicity. And it also promotes more soil life. Because if we apply lime and get the soil to an optimal range, then our soil microbes are going to do better in the soil. Right? And we talked about the importance of soil microbial activity. And also, if we increase that soil pH, the plants will perform optimally as well. So the following are available in the market now. We have calcitic lime, dolomitic lime, burned lime, and hydrated lime. Now, calcitic lime precipitates out of the ocean water. And after centuries of precipitation and layering, we get what we call limestone. Here's a limestone quarry in Morocco from the Mediterranean Sea. Here's another one way closer by, and this is in Lake Huron in Michigan. This is the United States' largest limestone quarry. Now we have dolomitic lime, which is manufactured in a combination of calcium and magnesium carbonates. We have burn lime, which is heated limestone, and this is driven off of carbon dioxide. And lastly, we have hydrated lime, and this occurs when you add water to burn lime, and it's just a little bit more stable than burn lime. So now I want to get into buffering capacity. The buffering capacity is the resistance to pH change. So this is a really important measure, and you can find out about your soil, and that you need to know this about your soil, so you can determine how much your soil pH is going to resist that pH change, if it's greatly or if it's not at all. So if your soil has a high buffering capacity, this means you'll need to apply more lime to increase the soil because it is more resistant to change. So now I want to get into a term called cation exchange capacity. So let's dissect this word a little bit. Cation are positively charged ions. Anions are negatively charged ions. So cation exchange capacity, or CEC, is a measure of how many cations can be retained on a soil particle surface. Okay, so CEC can determine buffering capacity because the more CEC results in a more ability to hold hydrogen cations, and more hydrogen equals more lime needed to neutralize the soil. So now we know what to do if a soil is too acidic. What should we do if a soil is too basic? So an issue associated with having basic soils is as some plants require acidic soils. A lot of evergreens and oak species require different more acidic soils, as well as like hydrangeas and blueberries and whatnot. They as well require this. So to decrease soil pH, you can use sulfur. Elemental sulfur, which is 90% sulfur, can be used to decrease soil pH. This is the best option to decrease soil pH because we have such a high percentage of actual sulfur within this amendment. And then we have the other two, ammonium sulfate. This is only 20% sulfur, so this is not going to be too good for reducing the pH. It could be used, but definitely the elemental sulfur is going to work a lot better over the aluminum sulfate, as well as the calcium sulfate or gypsum, which is also 20% sulfate. This is still not as good as reducing that soil pH because it's such a low percentage of sulfur.